In this video, we are going to look at a square root problem and using the definition of derivative to find the derivative of f of x equals the square root of x plus 4. So our derivative formula says we take the limit as h approaches 0 of f of x plus h minus f of x over h. Now, as we've done in the past, first we have to find what f of x plus h is. And we know that what that means is wherever we see an x in the function, we're going to substitute in x plus h. So f of x plus h here is going to just be the square root of x plus h plus 4. Then we know that f of x is just this, the square root of x plus 4. So this function becomes the limit as h approaches 0 of the square root of x plus h plus 4 minus the square root of x plus 4 over h. The way we approach this, oddly enough, is we multiply the numerator and denominator by the conjugate of the numerator. So recalling conjugates, write that here. A conjugate, if I have a plus b, its conjugate is a minus b. And often we multiply them together because the middle terms cancel. And that is actually what we're going to do here. So in my numerator, I'm going to multiply that by the conjugate of this expression, which would be the square root of x plus h plus 4. But then it's going to be plus the square root of x plus 4. So this red expression is the conjugate of this purple numerator because they changed the sign. In the denominator, we must also multiply by that same thing. Because whatever I multiply my numerator by, I have to multiply the denominator by. Now, multiplying this out will look like this. You'll take the first term times the first term. And what happens there is since they're the same, you're just going to get x plus h plus 4. Then, let me erase this. Taking that first term times the outside term will look like this. It'll be plus, because it's positive, the square root. And since they're both square roots, you just write it as x plus h plus 4 times x plus 4. All of that would be in the square root. Then we're going to take the middle two terms and multiply them. So we took the first times the outside. Now we're going to multiply the inside terms. So this is a negative x plus 4 times, or a negative square root of x plus 4 times the negative square root of x plus h plus 4, which similarly will just be minus the square root of x plus 4 times x plus h plus 4. And finally, we'll multiply last times last. So that will mean we're taking last term here times this. Now, since they're the same expression, they'll just be x plus 4. The square root of x plus 4 times the square root of x plus 4 will just give us the square root of x plus 4. But it will be subtracted because this is a minus times a plus. So that looks horrible, and that's what my numerator is. But notice that this expression, the square root of x plus h plus 4 times x plus 4, is exactly the same as this one, the square root of x plus 4 times x plus h plus 4. Those two things are in different order, but they are the same. And this one's being added and that one's being subtracted. So the happy part here is they cancel, which is why we multiplied by the conjugates. So our real numerator here, I'm going to rewrite this. Our real numerator here is this x plus h plus 4 times or minus x plus 4. And if we subtract x plus 4, we're going to subtract the x and subtract the 4. We'll distribute that negative. Now, my denominator doesn't look that happy, but we'll figure it out later. My denominator will be the h times this square root of x plus h plus 4 plus the square root of x plus 4. All right, let's look at our numerator. Here I've got the x's that will cancel, and the 4s, a plus 4 and a minus 4, will cancel. So all we have is an h, and that h. Rewriting this, we'll have the limit as h approaches 0 of the h in the numerator, and then the h times this denominator. Now, as you can see, we can cancel our h's. I have an h in the numerator and an h in the denominator. When you cancel everything, it becomes a 1. So what we get is the limit as h approaches 0 of 1 over the square root of x plus h plus 4 plus the square root of x plus 4. Finally, our last step is to take the limit. So this h will become a 0. So this expression in the first part is really just the square root of x plus 4, and so is this one, the square root of x plus 4. So our final answer is 1 over 2 square roots of x plus 4. You kind of had to take the long road to get there, but that is how that works. Let's look at our final problem, which is a word problem. Problem 8 says a company's total sales in millions of dollars, t months from now, are given by s of t equals the square root of t plus 4. Find and interpret s of 12 and s prime of 12. Use the results to estimate the total sales after 13 months and after 14 months. Use the derivative found in example 7. So here, let's look at what s of 12 would be. It wants us to find s of 12. Well, let's see if we can interpret this. T is months. And since t is our independent variable, what we're talking about with s of 12 is 12 months later. And s represents the sales. So s of 12 means the sales 12 months later. So if we substitute in 12 for t plus 4, we get the square root of 16, which is 4. But then they said it's in millions of dollars. So the way we'd interpret this is we would say 12 months from now, the sales will be $4 million. $4 million. Then it wants us to find s prime of 12. All right, and it said us to use the results from our prior problem. So if we go back, we did find the derivative of the square root of x plus 4. The only difference here is our variable is t. So that means s prime of t will be 1 over 2 times the square root of t plus 4. So let's write that here. So s prime of 12 would be 1 over 2 times the square root of 12 plus 4. Or 1 over 2 times the square root of 16. Or 1 over 2 times 4, because the square root of 16 is 4. So 1/8. Now, let's interpret this. 1/8. If sales is in millions of dollars, this is 1/8 of a million. If 1/8 of a million is $125,000. Now, we need to look at units. This is t months from now. So my numerator would represent sales and my denominator would represent months. So this answer, 125, is $125,000 per month would be the rate of change. Use these results to estimate the total sales after 13 and 14 months. So if we're going to estimate S of 13, and I know that after 12 months, sales was $4 million, and then per month, it's changing at $125,000 per month. So let's write this a little more accurately. Oops. 4 million looks like this, plus 125,000. That means we're at $4,125,000 in sales at 13 months from now. And at 14 months, we'd be up another $125,000. So we could write 4,125,000 plus 125,000. So that would be $4,250,000 would be our estimate of sales 14 months from now. All right. Thanks for watching.